we're going to introduce units. Before people can take this physics class, I'm sure you're required to take math classes. What's different between the math and physics is that in physics, we actually make measurements and we use units, which may not necessarily be required in math. So we're going to introduce three things. Measure with the units, we're going to introduce SI-based units and SI-based unit prefixes. And then I'm going to give you a big heads up, a big shout out, and just want you to pay a lot of attention to the symbols. And this could be something that can cause you get into a little bit confusion. So it's good to know ahead. And the last thing for this part is unit conversion, which is used in about maybe 40–50% of the problem solving. So it is very important that you get really good at this. By the end of the semester, you're going to be an expert on this. Okay, so 7 fundamental properties. These are the most basic properties. All the other properties can be combinations of these properties. For example, length times length is area here. So because these are the fundamental properties, we actually measure them in different, what called international base units. So these are the most basic units, and that's the unit system we use in all physics calculations here in this course. So for time is a second, for mass it's not gram, it's kilogram, and for length is meter. So these are the SI base units are for measuring the fundamental properties. Can we use other units to measure the fundamental properties? Yes. These properties can be measured with prefixes. So for example, kilogram can be used to measure mass. Milliliter can be used to measure volume. And microgram can be used to measure mass. These are different unit prefixes. It's actually a really good idea to know this because you're going to encounter them from place to place. When you see what is a pico, what's a nanometer, for example, it's really nice that you understand nanometer is 10 to the -9th meter. It's very, very, very small length. So these are the prefixes. Because these are widely accessible online, I'm not going to require you to memorize them. However, you do want to know these are the prefixes and you know how to use them. Okay, the symbol of units. Okay, so this is a big shout out, heads up. If you know this, you're going to know what they mean when you actually see these symbols. Instead of writing METER, we use M to represent symbol. If you remember, M was used to represent mass. So how come all of a sudden it's used for meter? Okay, look, these are units. That's where they belong. So when M represent unit, it's for meter. When M represent a property, it's for mass. So that is why I'm giving you this heads up. If you go over this carefully, you're going to know what they mean and you're going to be very clear about them when you see them in equations. In the equation, instead of writing NEWTON, we're going to write an N to represent Newton. Micrometer will be a prefix micro, mu, M. And there are some unit symbols that comes in 2 letters, inch, feet, candela. Do you know what candela is? Candela comes from the word candle. It's luminance intensity, how bright everything is. And there are complex units or combined units, we call them, meters per second for velocity, specific heat, joules per kilogram per degree Celsius. Cubic centimeter, that's what CC is short for, is really centimeter times a centimeter times centimeter. That's what we mean centimeter cube or cubic centimeter. Okay, so here are some basic rules we use for units. In calculations, in this course, we only use SI units. Only, that's a little bit extreme. There might be a couple of exceptions. So except the exceptions, we use SI units. It's always safe. When you solve a problem, when you see units, it's not SI unit, step 1, convert. Okay, SI prefixes. We used to require students to memorize them, but now I'm really thinking you can easily find them. Why memorize them? But I do want you to know them. You know where to look. Unit conversion factors can be researched again, and there's no reason to memorize them. Let me give you now an example. 25 miles per hour is the residential speed limit, and let's see what's meters per second for that. These are called the unit conversion factors. So these are basic equalities. 1 mile equals to 1609 meters. Do you see I'm writing M instead of meters? So that's a shorthand. It's an easier way. 1 hour is 3,600 seconds. 25 miles equals to what? So this is how you do the unit conversion. 25 miles, then how many meters per mile? Then you convert from miles to meters. Okay, 25 miles per hour. First is the 25 miles divided by the hours. 25 miles is this many meters divided by this many seconds. So the result is 11.17 meters per second. So this is an example of unit conversion. What you need is to know what you are converting from, what you're converting to, the unit conversion factors, and then the calculation. If you are completely clear about this, you're going to find it a lot easier to solve most of the problems. In case you're a little bit rusty with this, this is a great time that you go over this, ask questions, reach out for help, and make sure you know how to do a unit conversion before moving to next week. In summary, this is what we introduced. First, you make measurements always with units. Just like you wouldn't write a blank check, you would never give a number without a unit in physics. Okay, so the most safe units we use is SI-based units. That's what you use to do any calculations using formula or equation. Sometimes you're going to see units as not SI-based units because we actually use prefixes. When you encounter these units, the first thing you do is to convert them into SI-based units, and then you do the calculations. So I want you to know these SI-based units. Okay, the second thing is now you get a big heads up and shout out about the symbols of units. These units appears in a lot of places in simple form, and I want you to know what they actually represent. And because the symbols has a few different styles, if you get to notice them in the beginning, you're going to get clear as we move on. You know what they mean. So they are like little nicknames for the units. And unit conversion. This is really extremely useful because it just appears in a lot of problems. And we want you to be 100% comfortable and capable of converting all the units to SI-based units before you do calculation. I already said that 3 times. Convert all the units to SI-based units before you do the calculations.